Hey guys, welcome to this video. So today we will talk about one of the applications of divide and conquer algorithms, which is binary search, that is used to efficiently search for an element in a sorted array. So binary search is a technique where we reduce our search space to half and we keep on doing so until we find the element or our search space exhausts. So let's see how it works. So basically this is the algorithm that we use. Here we maintain two pointers. One is your start pointer, other is your end. Start points to the first element in the array and end points to the last element in the array. After that, we calculate mid, which is the middle of the array. So one thing is for sure. Let's say our mid is this. We are just taking an example, right? So all the elements that lie right side of it should be greater than this element, right? Similarly, all the elements that lie left to it will be smaller to it. We will be using this technique of a sorted array to reduce our search space. So after calculating the mid, we compare it with the key that we are searching, right? And if it is equal to the key, in that case, we return. So the index that we were searching for is the mid only, and we return that mid. Otherwise, we reset our start or end pointers based on the where our key lies. So let's take an example. We have this array where we have 8 elements, right? So we want to search for 30, which lies on this index, right? So initially in the first iteration, which is this one, right? So we set our start and end to the first and last indexes of this array. So start will point to first and end will point to this last element in the array. So with this calculation, our mid comes out to be 3, right? Now we compare this element 18 with the key that we are searching for, which is 30. So we know that 30 is greater than 18. So our element should be lying in this search space. So we can discard this part, right? So we reset our start. So with this logic that we had here, so we reset our start to bid plus 1, which now becomes 4, and end will remain as 7. Now we again calculate mid, and with the calculation it comes out to be 5. Now we compare the element that lies at this index with the key, and we were searching for 30 only, and it comes out to be equal to 30. In that case, we return this index. So this is going to be our answer, which is 5. Hope this is clear. And now let's see it in a code. So we will have one method here, one static method here, which will return us the index of the element that we are searching for. So let us create that method, public static int perform search, and the input of this method is going to be a list of integers, right? Let's call it a list, and we have one number that we want to search, right? So the idea is very simple. We will be having two indexes, start, which is 0 initially, and then we have end, which is nothing but a list of count minus 1, right? So these are the two start pointers that we have. Now let's write that while loop while start is less than equal to our end, right? Let's now find the mid, which is going to be start plus end minus 1, end minus start divided by 2. Correct. So what we will do now is we will compare this middle element. If list of mid is equal to num, in that case we will simply return mid, right? But if our list of mid is greater than num, in that case in this case, our element that we are searching for lies left to the mid, right? So what we will do is we will simply have end is equal to mid minus 1, right? Else we will have start is equal to mid plus 1. And if we don't find any number, in that case, we will simply return minus 1. So, yep, this is the code. So I have added this unit test element found where I have created a list and I want to find the index of 30 in this list. And as seen in the previous example, we know that the index comes out to be 5, right? So we are only checking this. This method returns the index in this variable, and here we are checking whether the answer is 5 or not. So let me run this unit test. So it gave me success. Awesome. So let's now add another unit test for not finding the element, right? So let me copy this unit test and add it here. Element not found, right? So I have the same list. So now let me add a number which doesn't exist in this list. Let's say I want to find 20. So 20 doesn't exist in this list, and our perform search, this method, so when it doesn't find anything, it returns me minus 1, right? So our expected answer should be minus 1 in this case. So let's see if this test case pass. Awesome. So this test case also passed. So we are good. Our code works. That's it for today's video. Thank you for watching.